Hi guys. So we're looking at, hope everybody's doing good and safe out there, you guys. We're getting close to the end of the semester. We're in week, I guess, 14 here. But we've got chapter 69 and 90 to kind of go over with. They kind of work almost hand in hand with ignition system that produce high voltage, as well as hybrids on chapter 90 that we'll be looking at. Basically, ignition systems, come from a long way. We used to have the points of condenser set up with the distributor type, of course, set up with a condenser or capacitor that help charge up the points, provide electricity coming from the distributor shaft all the way to our rotor, and then it got delivered to the distributor cap to the very top of the tower of that, going up to the spark plug wires and down to your spark plugs to ignite the air fuel mixture. Of course, we had a coil that helped and aided that process that was producing about anywhere between 10 to 20,000 volts. Now we're looking at over 100,000 volts in coil delivery on late model ignition systems. Plus, now we have multiple ignition coils compared to what we used to have a long time ago, which was only one that fired a V8, V6, or a four-cylinder engine. Now we've got a coil over plug design. Our CMP type setup, COP setup, coil on plug. So, basically we're looking at some of the components of the ignition system from the primary side to the secondary side for your information. I know we have a worksheet to kind of look at the ignition systems and kind of check for spark and stuff like that I'll probably do some demos on for you guys as well. So, but typically on the primary side, we're looking at the ignition switch, the wires going to it, the primary wiring that goes to our ignition coil, which is anywhere between 10 to 20,000 turns of fine wire and about 150 to 250 turns of heavy thick wire. And they're wrapped around a laminated iron core that kind of helps out with reducing magnetic induction to help increase the voltage setup that we get coming out of our spark plug wire, which typically, like I said, back then was about 20,000 volts. We're seeing over 100,000 volts now. So we kind of look at that triggering device that comes out of it, guys. We have a pickup coil and a module that kind of work together hand in hand, that sends out that signal to our ignition coil to help deliver that spark in a firing order, sequential order. Every engine design has got a specific firing order that it has to fire, designed by the manufacturer. So we need to, especially when we're dealing with spark plug wires, we need to make sure we carefully put the spark plug wires, if we have to replace them, put them back exactly in the same spot that it came off of. Otherwise, we're going to have a tremendous amount of misfiring, or it could even no start, or a backfire condition can occur. So typically our pickup coil is a reluctor wheel, and it rules on a permanent magnet called an ignition module. And what that does is help increase voltage, helps reduce voltage every time if you're looking on page 784, where the reluctor wheel moves around the permanent magnet as the two tangs together is building up this electricity and current flow going through it. As soon as it passes it, boom, it reduces the voltage to the coil. So if that's not working correctly, then we can have a problem with a no start condition. So I know I've had replaced several hundred pickup coils and modules in my time with drivability concerns, as I was did a lot of drivability work a while back, but that's kind of how it works. So that principle stemmed up later to what we now have. We got a camshaft sensor, we got a crankshaft sensor that kind of work together for timing and for spark delivery. That goes to an ignition module. Well, now it's no longer an ignition module that can't be replaced anymore. It's more in the PCM now. So if the module goes bad, then the PCM has to be replaced if it's found to be defective. Typically, there's been all kinds of modules that have been initiated in the past, from a distributor mounted module inside a cap to externally away from the cap on the distributor shaft housing to the firewall, where it was easily replaced at the firewall area, and now they did away with that. So now it's basically inside the PCM now. So keep in mind that the The module would also be considered a permanent magnet, which it would rotate. It's got a triggering device that would help trigger voltage going to our ignition coil. And on page 785 and 786 there, it kind of gives you another signal of what we're looking at on late model cars called a crankshaft sensor. So the crankshaft sensor is designed to help pick up that reluctor wheel, which would have been the pickup coil. Now we see it now. Normally, sometimes it's installed, the reluctor wheel is normally installed by the crankshaft area, usually by the pulley, or inside the crankshaft area with a crankshaft sensor mounted on the side of the block. And then there's also some crankshaft position sensors that pick up the signal by the flywheel area that I've seen. I know some Chryslers were like that. When I worked at the Chrysler dealership, their crankshaft position sensors were picked up in the back by the flywheel area. So, but it basically has to be synced up and set up automatically. Of course, on distributor type systems, when you have to deal with ignition timing, you have to adjust it. Now, late model vehicles, there is no adjustment on timing. It automatically is adjusted by the computer based on inputs that it gets throughout for the sensors that are on the vehicle. On the firing order sequence, like I said, the vehicle's got on page 787. If you look on the very top on figure 6912, there's a typical firing order of a V8 cylinder engine. That one right there happens to be one that we've seen from Chevrolets and Chrysler vehicles. They pretty much have the same firing order sequence. The only manufacturer that doesn't were the Fords. They had actually two of them, two different ones that you had to know how the firing order was. Otherwise, you would have crossed those wires left and right. And it probably, if you did it the wrong way, it wouldn't start at all. But the coil on the plug is what we see now on a lot of late model vehicles on page 790 and 791. It kind of shows you there a picture of what it looks like. You know, there's no spark plug wires that we have to deal with anymore. That was causing an issue in the past for some people that didn't understand this at this point. Now we have more coils per each cylinder. You know, 4, 6, 8 cylinders. You know, we got 12 cylinders now, 16 coming up. You know, we have that now. We no longer have spark plug wires that go to these. So basically, these are the COP systems, the coil on plug, that we look at. A little bit more beneficial, yes. However, when the coils go bad, they need to be replaced. You know, they could be expensive. It could get expensive, 70, 85 bucks a coil times 8. There you go. So typically, we're looking at how it flows in there. You'll learn more about that on the engine performance side of it, but understand that we can check the voltage signal. We can check to see what the voltage is. I mentioned the sparks on that. You'll see if it's a good healthy spark, it should be a blue spark. A red orange spark is going to be a weak spark. A white spark normally indicates the coil is not really getting ready to go out. It's producing a very less spark, which will cause a misfire. And of course, the last one is a no spark, which is not good. That'll put you in tennis shoe mode, by the way. So fast forward the ignition, the high voltage side, we get into the hybrid safety system on page 991 on chapter 90. Understand we're looking at, you know, a 42 volt system on this one, 144 to 600 volts with the orange cable wire, which is very, very high. You know, we got 300 amps that can actually fry a person pretty severely. And we have the vehicle on a hybrid protected by a 300 amp fuse, normally located in the back of the vehicle, or it could be located behind the seat of the vehicle where we have the high voltage battery pack. There's a couple of things that we need to know about this, safety precautions. There's some gloves here that we look at on 992 and 993. I typically would be able to show you those in the classroom, but we don't have access to that right now. So these are what the gloves look like. You got rubber lining gloves, and then you got the leather gloves that go over it. So those have to be checked and dated and replaced very frequently. There's a very quick way to test it on page 992 on figure 90-3. You basically just take it over, roll it apart, and you got to wait within a minute or two. If it starts to leak and deflate, that means you got a pinhole in it and replace it. And you got to replace it respectfully and dispose of it properly, by the way. Okay. And typically the dealerships are the only place you can get this done, unless anybody in the independent side is a hybrid certified to work on a specific type of vehicle. You won't be able to do it in a shop. Multimeters are used. Got to make sure you have a Cat 3 rated multimeter to check for available voltage. Fluke is one of the main leaders in that, and they usually have a good meter for that. When eye protection, of course, must be worn at all times. Safety cones have to be displayed on the four corners of a vehicle. And then you also have a fiberglass pole, what we call a Moses stick. It's a big old long fiberglass pole. It's about 8 feet long, 8 to 10 feet long. And that's in the event that if somebody was to touch the vehicle and they started getting electrocuted, you want to use that fiberglass pole to remove them from it. So that has to be readily available in the stall, close to the technician, close to the vehicle. You do have an auxiliary battery, a 12-volt battery that goes in the back, but typically the auxiliary battery is only a backup battery. It's an AGM type of battery, and that's used for the lights and various other small voltages. It's not used in conjunction with the high voltage battery. That battery gets charged through the transmission. Okay, so especially during a decel condition, during regenerative braking, that's when we see quite a bit of amperage being drawn from the transmission over to the battery for that, because it increased friction. Of course, anytime we work on a hybrid battery, you definitely need to make sure that you disconnect the fuse first and wait for an allocated amount of time. While you're working on the vehicle for whatever reason. Typical things that can be done to it, or regular maintenance items that can be done for it, like oil changes and air filter services, brake and steering. You can pretty much work on those things. Just got to be careful with the high voltage area around it. When you're doing oil changes, you want to make sure that when you have the vehicle set up and you lift it up, that you don't be careful and mindful with the high voltage cables that are on the sides of the vehicle. They're typically covered with a cover, but so you don't want to put the lifting leg arms out there and damage the cover, which will actually pinch the cables, and then we have a big time short in an electrical fire. The other thing that you want to be mindful about is when we have the vehicle up in the air, the key fob that normally you get with the hybrid vehicle, it needs to be 15 feet away from the car. Do not put the keys in your pocket where you're doing an oil change. It needs to be 15 feet away from that. And the reason behind that is because it prevents from accidentally starting the vehicle all by itself, which has happened in several lube places, and I've heard of a couple of them, but one in particular, a guy was doing an oil change, and he had the key in his pocket, and he had drained the oil already, went to go get the parts, and all of a sudden the car started by itself. And there was no oil in the crankcase, so it wound up locking up the motor. So, and that was because he was not unaware of the fact that, you have to put the keys 15 feet away from the vehicle, so the computer does not sense a key fob. So that's prevented from accidentally starting. So just kind of keep that in mind. 15 feet away from it is the key right there. Typical oil viscosity, 0 weight 20 is used on hybrid vehicles to help out with the engine when it does start, when it's not electric power mode, for better fuel economy. Because it's a need also because of the need for fast lubrication, because the engine and idle stop feature happens right away. So we want to keep that engine turning with a lower viscosity type of oil. So that's why they normally generally go with 0 weight 20. Okay, so keep in mind and look at the manufacturer specifications on that, guys, because that's kind of important. on page 1000 all the way through. It kind of gives you a preview of the gloves and when they're dated, how to test them. Just always be sure that we're looking around. Those of you who do have a hybrid vehicle, consult with your owner's manual, and just if you're able to do certain things that you can with it, only do what's the general maintenance thing, because you still can do the maintenance items on it. As far as the AC system, I wouldn't service it because the AC compressor is high voltage. So if you need a compressor, if it goes out on you, more than likely it might be under warranty. So take it to the dealership. They're the ones that are certified to work on it. They're the ones that have gone through the training on it, because it's under high voltage, guys. So a couple of things that you want to look at. If there are no items that you can't do or you're in doubt with doing, always consult the owner's manual. But typically, to general small maintenance things you can do. Brakes, you can take the brakes, take the tires off and check the brakes. If you need to do a brake job, that can be done. Suspension components, they can still be replaced. They're not under high voltage. So that's some of the things you can do to the vehicle. But all the other rest, I wouldn't mess with it. Not until you've gone through the training, which is an extensive training that the technicians have to undergo. So leave that up to the dealership guys, because they know what they're doing. Next thing we'll look at doing a couple of demos with the scan tool. That'll be forthcoming this week. So you guys be safe and take care.